So they want us to draw a picture that's not increasing or decreasing. That means we don't have a change of y. We don't have a change in y because we're not increasing or decreasing. Oh, so the slope is 0. Well, aren't they all straight lines? So what kind of straight line? Because if it's not increasing or decreasing, its slope is 0. Yeah, we have no change of y because that's what makes us increasing or decreasing, our y. But I thought all of them were straight lines. So can we be more specific about the kind of straight line it is? Use our math words for it. Because aren't they all straight lines that we've been doing? Yeah. They've all been straight lines as far as I know. We haven't done any curves. We've done relationships that are curved-like, but we haven't actually done a curved line. So all of our lines have been straight. So we need to be more specific. What direction is it going if it's got a slope of 0? What math word do we talk about that is a line that goes side to side? What's our fancy math word for the lines that go side to side instead of up and down? Because this is what we mean, right? We've got this kind of line. So what does that mean for us? What's the math word for the lines that go side to side only? Starts with the letter H. You do that in. Oh, I want to be bigger font. This line will have no slope. So it starts with the letter H. The math word for the lines that go sideways starts with the letter H. Remembers that math word. It has an H-O-R on it. How about that? I know it's early. Horizontal, yeah. Okay, so does it matter where on the graph we draw our straight horizontal line? Nope. I'm gonna be red writing. I'm gonna put mine through this spot right here. But I should probably be on the line setting, right? And since it is a line, it does continue forever. So I need to put the arrows on the end. And we have to identify what this line is. Now, if it's going straight sideways, a part of it's not changing, right? What part is not changing, the X or the Y? The Y. So this is a Y equals line because the Y is not changing. Y equals what for this particular problem? What does my Y equal? Look where we drew it through. Y equals what? 4. So anytime we do not have a slope, the equation goes Y equals. That's because slope was 0, right? And 0 times an X made the X go away. But it still got a starting point. It still has a start, right? Oops, I gotta get this to 4. Still has a start because it's crossing the Y-axis. And that start is still at 0, comma. It happens to be 0, 4 for this one. But anytime we're talking about a line with no slope, the line is going to go y equals, because the slope was 0. And 0 times the x made the x go away from our format. But since they weren't specific, we could have drawn it anywhere as long as it was going horizontal. Okay. So we need this one to be decreasing non-linearly. So non-linearly, this phrase right here, non-linearly, means what's happening with my line. If I'm non-linear, what kind of line I am. What kind of line is it? It's curved, yeah. So non-linearly equals curved. Okay, now it has to be decreasing, which means as the y's go, as the x's go up, the y's come down. Okay, so you do have to use the drawing tool because you cannot draw a curve with the line tool. That'll only do straight lines. So we have to use the drawing tool. And as long as the y's go down as the x's come up, we're good. All right. And it could have been anywhere. It could have been down here. It could have been only in this quadrant. Could have been only in that quadrant. It's just as the y's come down, the x's are going up. Okay. This one has us doing two things. That's weird. First, it says increases linearly. Then we have to decrease linearly. So I have to go two directions. And both directions have to be straight lines. So I can use my line tool. Okay, linearly means it's doing what? What is linearly doing? Straight line. So first we have to straight line that goes up. Then we have to have a straight line that comes down. And we put the arrows on the end. Okay. In this case, the x and the y were both going up. Then all of a sudden the y starts coming down. Okay. Graph that has a that is consistently increasing. So it means it's only increasing. So we can use our line tool. Has to head upward. Oh, 1 second. I want this one to be blue. Consistently increasing, right? Could I have put it anywhere on my graph? Yes. Yes, I could. And actually, we have an error because consistently means my line's doing this. This is consistently. Oops, what kind of line is this? If the flat line was horizontal, then this one must be what? Vertical. And like the horizontals, their equation gives the letter, so this is going to be an x equals. And in this case, it's an x equals, looks like 5. Okay? Because there would be no y. The y wouldn't be changing. It's the same x over and over and over and over and over. Okay, so these are different looks for graphs. Okay? Now they're going to have us talk about this thing called a function. Okay? The function works like a machine. The numbers are put into the machine one at a time, and then the rule is performed on each input. For example, when x equals 3 is put into the rule, 5x minus 7, the rule multiplies 3 by the 5 and then subtracts the 7 to get us 8. So it gets us the ordered pair 8, 3, 8. Okay, so we've done things like this with the table. They're just calling it a function machine now. Then it's put on the XY coordinate plane. Okay, so we're just substituting the letters, the numbers they tell us, just like we've done before. Okay, they just call it a function machine right now. And I'll be explaining why in a second. So find the output when the x is 4. So we get our equation. What was our equation? They told us that our equation is y equals 5x minus 7. I substitute in the 4. Y equals 5 times 4 minus the 7. I do the math on the 5 times the 4 and I get what? I do the math on the 5 times the 4 and I get what? $20. So this is going to now say 20 take away 7, and I do the last step of the math, and I figure out that the y equals what? Do the final step of the math. What do I get? $13. So my output is y equals 13. Now I want this one. But my final answer is an ordered pair. What ordered pair would I say this is? What ordered pair did we just figure out? X of what, y is what? Make it an ordered pair, just like we did for our table of values. Just like we did for our table of values. So 4, comma, yep, 13. So all this is the same as our table of values. They're just doing it in a different format, all right? Don't think of it as anything different than the table of values. So they want us to figure out 2 more. Working smart, not hard. I'm going to go copy my equation. And I'm going to go copy the work for the equation, working smart, not hard. And I'm going to put that in 2 spots because I have to do 2 of them. I don't need the equation twice, I just need the work twice. The first one is going to be a -1 for the x. The second one's going to be the 10 for the x. Okay. Okay, solve the math for the -1. What is it going to say? 5 times -1 gets me what? Do our math. 5 times -1. -5. And then we have to combine it with the -7. So what do we get? A -5 with a -7 gets us what? Negative 12, because they're both negative, we add and keep that negative. But we need the ordered pair now. What would the ordered pair be for this situation? What was our x? And what did we figure out our y to be? Negative 1, comma, negative 12. Yep. Okay. Questions about it? Is anybody having a hard time with it? Okay, let's go finish this other one. What would my next step be? Solve the multiplication. Solve the multiplication. What would I get? 50. Okay, and then I find the final answer. What am I going to get? 43. And what would my coordinate pair be? So like I said, you guys had already been doing stuff like this. So this shouldn't feel super scary. It should be kind of easy, actually. I want to fix something. I want this box to be red because it's blue writing. And then I'm going to change my box to blue because it's red writing. Makes it stand out more. Okay, anybody questioning about that? So it's the exact same process we took to make our table of values. They're just calling it a function machine. Okay. So they want an output of 45 and they want to know what the input is. That is, if y is 45, what would the x be? So we're solving this in reverse. We know the y this time. We need to figure out the x. So we're going to get the equation. Okay, we're going to get the equation. And then we're going to substitute into the equation the y they told us they wanted this time. Instead of putting in for an x, we're going to put in for the y. And then we're going to do our big zeros and our big ones. Okay, so what do I have to move first? What do I have to move first? The -7. How are we going to move that -7? What do we got to do? Add the 7 to both sides, exactly. So this is, we've already done this stuff. Add 7 to both sides. Because whatever we do to the left, we have to do to the right. We have to keep the balance. That made big 0. What does this clean up to be, though? Keep going. I want the whole line. What does the whole thing clean up to be? Ah, 52 equals 5x. Okay. Are we done with our big zeros? I knew it was a big 0 because I saw this subtraction. Am I done with my big zeros? Yes. So I move on to my big ones. I got to get rid of the number with the letter. I have to get rid of the number with the letter. What am I going to do to get rid of that number with the letter? Okay, divide both sides by 5, yes, because that's the number with the x, and I know a number stuck to a letter means multiply. So to undo a multiply, I have to divide both sides, yes. Okay, so I'm going to divide both sides by 5. So I'm going to have a 52 over a 5 equaling a 5x divided by a 5. And we know we use our equation writer so that that comes out looking correctly. No slashes with things in the same row. That will make the 5s disappear because 5 divided by 5 is 1 and we don't write 1x, right? So I need to final answer this. How would I final answer this? Nope. We don't do decimals. We talked about that. We're not wasting our time with that. The x does go on the left side though. So x equals 52 over 5. Stop wasting your time and making decimals you don't need. You don't need mixed numbers. You don't need decimals. You don't need any of it. Okay. So we found the x that would make the y equal 45. Okay, we found the x that'll make the y equal 45. And it says, is there more than one possible way to get an input for 45? Could we have had another x? Was another x a possibility in any way? If we had solved this differently, would we have come up with a different x? Following the rules? No, we won't. So, is there more than one possible input for this output? Is there more than one possible input for this output? No. So now we're going to go ahead and we're going to write our sentences, answer things. The input would need to be, what did we say our input had to be? X equals, remember I taught you the guys this trick? 52 divided by 5. I want this to be red so it matches my sentence. Space, 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 space to get past it. To have an output of y equals 45, right? That's what we figured out. And we answer the second part. Is there more than one possible input number for this? No, there is not more than one input for the output. I know, but I don't necessarily want to jump that far. Spacebar works for me too. Okay, so because there's only one input for each output, that's what makes it a function. Okay, so we're going to put in great big capital letters in red. A function is when there is one input for every output. Okay, that is the definition of a function. When there is a one-to-one relationship of one input to one output. Oops, I can't spell. This means you cannot have one x going to two different y. Okay, every input has exactly one output. So I couldn't have 52 over 5 going to another different y. Okay, I can only have one x going to one y. Now, can the y repeat? Yes. The y can repeat, but the x cannot. All right? So if I'm looking at a table of values and I see two x's that are the same x, I know it's not a function. When I'm looking at a graph and I see there's like two x's on the same line that are the same x, I know it's not a function. It has to go one x to one y, but the y can repeat. X cannot, y can. Okay, we got that? X cannot repeat, y can repeat. So they're going to have us play some more with these function machines. Okay. So I see the number down at the bottom. Is that an input or an output? Is the number coming out an input or an output? It's an output. And what letter stands for our output? Which one of our letters is an output letter? Oops, I don't want this capital. The X or the Y? Okay, so that's our Y. So we know the Y. We need to figure out the X that made it work, just like we did up above. So this notation right here, this weird stuff right here, f of x. This is red, f of x. I don't want a capital F. Okay, so we say f of x, which means function of x. Okay, function of x means that for every x, there's going to be one y output. Okay, and that's what that weird f parentheses x means. It means every x I put in will work. Okay, so I am going to solve this because I know my output is 20. So I'm going to solve that 20 equals my 2x. And I got to figure out what was the x that made that work. What do I have to do? I've already got it in balance beam format, right? What do I have to do? Do I have any big zeros to deal with? Do I have any big zeros to deal with? No, just a big one. Okay, I just see a number with the x, no pluses and minuses. So I'm getting rid of this 2. And like Lily said, we're going to divide both sides by that 2. Okay, so that's the 20 divided by the 2 has to equal the 2x divided by the 2. That made my 2 go away. And my final answer for my x is what? X equals what? 10. Okay, and then how would I write this as an ordered pair? Because that's ultimately what we're making, ordered pairs. What would my ordered pair look like? Yeah, 10, 20. So it's the same stuff we were doing earlier. It's just now they're making this cute little machine. How do we say this weird thing at the front again? What am I going to call this right here? f of x, which means function of x. Okay, which is the same thing as saying y. Okay, so what did they give us this time? This -3 up here. Is that an input or is it an output? Okay, up at the top, yes, that is an input. So if it's an input, which letter is it? X or Y? X, yep. So they told us the X is 3, -3. So I have to take my equation. Function of X equals -6 times -3. Because we're trying to find when the function is. So I solved the math. Function of X, f of X, equals how much? Do the math. $18, because -3 times -6, negative times negative is positive, positive 18. Now, if I'm going to write this as an ordered pair, what would I write? What's my parentheses going to say? -3, 18, yes. I'm going to stick that 18 in this little box. All right, so don't overthink them. Now, what do you suppose number 3 is called? That's not an F. What is that? That's not an F at the beginning. What is that? A G. So do you think they're going to use a totally different name? No, it's G of X this time. They'll go back and forth between F, G, and H usually. They'll go F of X, G of X, H of X. They still mean the same thing. They still mean the Y. Okay, so we have this value down at the bottom of 12. What is that? Input or output? Is that 12 an input or an output? It is an output, which means it stands for what letter? The Y, which is another way of saying F of X, G of X, remember? Okay, so it's replacing that G of X. So the 12 has to equal, 1 minute. The 12 has to equal a 2x minus 1. No big deal. Balance beam ready. What needs to move? Oh, I see a big 0 possibility. So how am I going to fix it? That's right. We undo a -1 by adding 1 to both sides. Nice. Add 1 to the left. Whatever we do to the left, we have to do to the right. So we add 1 to the right. The ones are gone. What's the simplified version of this going to look like? Do the math. Got to make it smaller. What are we going to do? We'd have 13 equals 2x. Yes, exactly. I'm fixing my size because I wasn't going to have enough room. I've learned how to do this. Boop, grab you, move, grab, over, grab you, move you over. I'm getting better. Okay, so we now have 13 equals 2x. What do we do now? 13 equals 2x. What do we do now? Yep, divide both sides by 2. Gotta fix this over here. So we're gonna have 13 divided by 2 equaling 2x divided by 2, right? Same as we've always done. Do we waste our time with decimals? Do we waste our time with mixed numbers? No. So what are we gonna say for this? X equals 13 over 2, right? What's our coordinate pair gonna say? What's our coordinate pair gonna say? I'm gonna copy this up here. How are we gonna write these two numbers, the input and the output, as a coordinate pair? Yep, 13 over 2, arrow off, comma, 12. Okay, so just because it's an improper fraction doesn't mean that it's not part of a coordinate pair. It's still part of a coordinate pair. Okay. All right, so did they give us an input or an output? Did they give us input or output? They gave us output because it's at the bottom. Remember, we talked about outputs are what comes out at the bottom. Inputs go in at the top. Okay, so this is an output, which is the same thing as the y, which is the same thing as an h of x or a g of x or whatever. Okay, those mean the same thing. M of x, that's a y. Anytime you see that notation, h parentheses x, m parentheses x, f parentheses x, those kind of notations tell you it's a function. They're telling you that there's one x for each y. You're not going to have the same x going to two different y's. Okay, so that's an output. So how would I write my work? If that's an output, where do I put it? How would I write the start? How would I write the start? If that's an output, what would my first line of my work look like? Yes, 12 equals 5 minus x. Yes, because the output replaces the f of x, g of x, h of x, the y location. Okay, now I have to do my big zeros and my big ones. I have to do my big zeros and my big ones. okay? I see an adding or subtracting of a number. I need to make the number move. What am I going to do? What am I going to do? Subtract 5 from both sides. Yes. I know I see a negative in front of my x, but that doesn't mean I do anything about it. And I don't do anything about them because I notice there's not a second x. Okay, there's only one x, so we have to leave him alone and work with the two numbers. If anybody was wondering, why did we pick the 5 and not the x? It's because I see two numbers, not two letters. Okay, so if we do our math, what does it look like now? Watch out for signs. What does it look like now? Do the math. Watch out for signs. Yes, 7 equals negative x. That negative sign was still with the x. It hasn't gone away. There's a hidden number in front of that x. What hidden number is there that we know is there all the time? Because we don't multiply by it, it doesn't help us. Yes, so this is really saying negative 1x. Okay, that's really saying negative 1x. So I have to big 1 away this negative 1. So how am I going to big 1 away the negative 1? How am I going to big 1 away the negative 1? Same as if it was a 5 in front of the x. Just this time it's a negative 1. So what are we going to do? Not by 1, by negative 1. You've got to take the entire number. So I have a 7. Well, I'm going to actually do it the negative 1x that I'm going to divide by negative 1. And that has to equal a 7 divided by a negative 1. Well, what's that going to be if I do that math? The negatives are going to be gone for the x, right? And my final answer is going to say what? And then tell me my coordinate pair as well. Tell me what the input had to be. And tell me my coordinate pair. Solve the math. What did we get? X equals negative 7. So what would my coordinate pair be? So what would the coordinate pair be? Yep, negative 7, 12. All right. Couple more. Does it matter that they changed the letter that's in front from a X or from a F to a G to an M to a H to a, is that changing anything for us? That they're changing this front letter? No. So don't stress about the front letter. Just remember, this is telling you it's a function. It's telling you you're going to get a single x matching to a single y. Okay, so what are they giving us? Input or output? What is this to? An input or an output? This 2 down at the bottom? Always at the bottom, is that an input or an output? Yeah, it's an output, which means it's replacing the y. And we know the y is before the equal sign. So my equation, because I'm replacing with the number they told me, 2, 2 has to equal 8 minus 3x. And we have to solve for that x. I see its balance being ready. I see a big 0 we need to deal with, 2 numbers. What do I have to do to zero that out? What do we have to do to zero it out? So remember, when it's at the bottom, it's always an output. Okay, subtract 8 from both sides because I see it as a positive 8. I agree. Okay, when I do that, what do I have now? What's my equation say now? We have to do our math. Negative 6 equals negative 3x. We knew it's a negative 3x because we saw a minus in front of it. Okay. My big zeros are done. I'm on the big 1 because I only have something with an x attached. I'm on a big 1. What would I do now? I have to big 1 that negative 3 away. Same way as I big 1 of 5. It's just it's got a negative sign with it. So what are we going to say? How are we going to get rid of what's in front of the x? Divide both sides by negative 3. So that's a negative 6. I have to move it here. There's not space for it. Highlight it, divided by a negative 3 has to equal a negative 3x. Highlight it, divided by a negative 3. You have to highlight it or it puts the negative in front, and we don't want the negative in front. We want it with the number. So my negative 3's are gone. How would I say my final answer for this? How would I say my final answer for this? What is a negative 6 divided by a negative 3? X equals 2. So my coordinate pair would be what? Two, 2. Yep. All right, last one of these with the function machine showing, and then we're going to do some without the function machine showing. Okay. Then we're going to do some without the function machine showing. We're just going to use it in function notation is what they call it. Okay. So did they give me an input or an output this time? Because we're up here at the top. So is that an input? It's an input, which stands for what piece of our equation? The x. So we're going to replace the x in our function with -5. What did we notice about our function this time, though? It's got something more. What does it have? Look at the function. Look at the equation. What does this equation have? The other ones didn't. Look at the structure. What does this equation have that the other ones didn't? Compare the one above it to this one. What does this one have that the other one didn't? An exponent. So be careful. We learned our exponent rules for a reason. 3 parentheses -5 to the second power, arrow off, -2. According to PEMDAS, we have to deal with that exponent first, right? So we have to solve that -5 squared first. What is -5 times -5? Because that's what -5 squared means. What is -5 times -5? -25. Not -25 because negative times negative is positive. Now we solve the 3 times the 25. So what are we going to get? What is 3 times 25? $75. And we're supposed to subtract 2 from it for our final answer. So our final answer is going to say f of x equals how much? Do the math. 73, but we need an ordered pair. So how are we going to word this ordered pair? So the 73 is the output. Oops, right idea, wrong button. $73 was the output. How do we make the ordered pair for this? -573, yes. Now, yes, things that have powers are still functions. What makes it a function is not about what the original equation looks like. What makes it a function is the fact that every single x in the problem is linked to a separate y. So if I were to look at a table of values, no x's would repeat. If I were to look at a graph, I wouldn't have any curves that come back either to the left or to the right, because that would make an x repeat. So now we're looking at this bottom piece. So they want us to look at these as without the function machine, without having to have that in the way. So when we're looking at this and they give us a number, they gave us an X. Okay. If they give us the number inside the parentheses, they give us an X. If they give us the number outside the parentheses, they're giving us a Y. All right. Numbers inside are X's. Numbers outside are Y's. So they gave us my function up here. In number 7, they gave me an X because I see it's in the parentheses, replacing the location where X would have been. Okay, so that's one way to remember. It's in the parentheses where the X would have been, so it's an X. So I rewrite this. My function, right, g of X, when 8 subtracts -2. Because they gave me an X, it says subtract in the equation. My X happened to be negative, so I need the parentheses. What happens with this parentheses though? What does minus of a minus really make? Remember, minus means opposite of. So what that says, if I were to say it in words, is what is the opposite of -2? Because negative means opposite, subtraction means opposite. What is the opposite of a -2? +2. So what they really meant for you to say is 8 plus 2, because the opposite of a -2 is a +2. So we need to finish solving. What is my function equal? What's my output? If I put -2 in, what output do I get? What's my coordinate pair? So I need my solving. My function equals how much? 10. And then I need my coordinate pair. -2, 10. Okay, and those are combined, the answer. So this one, they gave me outside the parentheses. So I know they gave me a Y. So that's replacing the G of X part. That's replacing the G of X part. So this says that 3 is going to equal 8 minus X. Make sure this is equal sign. Okay. I need the X alone. I need to big zero something. How am I going to do that? Subtract 8 from both sides, yep. So this is no different. It's just written in another format. Subtract 8 from both sides. What's it going to say now? Do the math. Do the math. I need the whole thing. What would it say after we did that? -5 equals a -x, because I saw that there was a minus in front of the x. It doesn't disappear just because the 8 goes away. What's in front of this x that we know is there but do not see? A 1. So this is really -5 equals -1x. What do I need to do to big 1 out of there? A number in front of the x. What would I do for this? No different than if it had been a 3 in front of the x. Just because it's a -1 doesn't change that. If it was a -5, it wouldn't change that. Whatever we do, if there's a regular number in front of the x, we would do now. So we have to divide what? Both sides by -1, exactly. So I have a -5, and I have to highlight it, divided by a -1, arrow off, equals a -1x divided by a -1. And yeah, you have to highlight it or remember the negative sign doesn't go in the right spot. So what do I get as a final answer, and what would my ordered pair be? What do I get as a final answer, and what would my ordered pair be? Yes, we know that when we're dividing, we just divide by the number. Letters stay. What's my whole answer? And what's my ordered pair? There's my ordered pair. I need my whole answer. How would I rewrite this final answer for this math that we just were doing? Oh, x equals 5, which is what gets me the ordered pair 5, 3. Okay. Oops. Not what I want. All right. Next one. What did they give me? An x or a y? It's inside a parenthesis. So did they give me an x or did they give me a y? Did they give me the x or did they give me the y? The x, because it's inside the parentheses, it's the x. So we're replacing the x in our function. And really and truly, I just realized, and let's back up for a second to this one. Whenever we replace the x, we change this to what we're replacing the x with. So it should say g of -2 to remind us what we were replacing with. Okay, so if they give us an x, we tell them with our work what it was that we were replacing. Okay, so this one's going to have that same thing happen. I'm going to have a g of 4 equaling 8 minus 4, because I replaced the x in my g of x with a 4. So if we do the math, what do we get? My function at 4 would be equal to how much? Also 4. So I'm done with that piece of it. I now need the ordered pair. How would I write its ordered pair? So don't overthink them. Okay, so turn that in. I think we got far enough that you'll understand what you're doing. All right, and you have the worksheet for homework. Turn in what we've done. I'm just going to grade to that point. Okay, and tutoring is at 2:30. So if you need help for the homework, come to tutoring. We're running out of time for you to fix stuff. All right, have a nice day.